Hey, welcome back. In this video, we're going to talk about box plots, or also called box and whisker plots. Box and whisker plots are just a graphical representation of a 5-number summary given a set of quantitative data. A 5-number summary is very straightforward. It just uses concepts we've recently talked about. You'll need to know how to find the minimum, the first quartile, the median, the third quartile, and the maximum of a set of quantitative data. Really, the tough work of a box plot is just finding the 5-number summary, and then I'll show you after we do this work how you create this visual representation. In order to illuminate this concept, what we're going to do is take this list of data. This is a list of 50 founders of startup companies at the age of the first time they had a successful startup. As you'll look through this list, there's some interesting companies and names. You know, we have at the very top there, we have Bill Gates and Mark Zuckerberg, obviously the founders of Facebook and Microsoft. At age 20, I'm feeling a bit old. Let's find somebody older. Oh, we got Jeff Bezos here. Jeff Bezos founded Amazon at the age 30. But all right, you get the idea. We have this list of these founders by the age. What we want to do is to find the minimum, the first quartile, the median, the third quartile, and the max of this data right here. Now, if we had a very small set of data, we could do this all by hand, but I have this list in Google Sheets, and I want to walk through how you can find these values with Google Sheets, and I'll transfer them here and then create by hand this visual representation of a box plot. So now I'm going to use Google Sheets to find the 5-number summary, the value for each of these 5 numbers I'm looking for. I just want to take a second and talk about how I'm going to do this. What I'm going to do is I'm going to write out the syntax here on the board and then also type it in just to make sure it's very clear and obvious what I'm doing. But importantly, what I first need to do is describe the range of values. This will always be important if I'm in Excel or Google Sheets and trying to analyze a set of data. Importantly, if I click on my first data point here, that first data point occurs at the cell B3, where B is the column where the data is, and 3 is the cell. You can see that I've clicked on that data point right there. And if you look up, it highlights the B and highlights the 3. We always put the column or the letter first and then the number of the cell. Then if I scroll all the way down, I will see that the data stops, obviously in the same column, but in cell 51. Again, you don't have to do the work of typing these in. Often you can just drag and select all that data, but it's useful to know how to do this by typing it out if you need to in any context. So first of all, let's just start doing the work. We're going to need this range of data for each of these. If I, in my little box over there, so under min, I'm going to write equals because I want Google Sheets to calculate something for me. And I'm going to write the min and then this range and put parentheses around it, hit enter, and I see that 19 is the minimum age of these founders on this list. Now I need to find the first quartile. What I'm going to do then in that box under the Q1 is I'm going to type in equals. Again, always start with the equals when I'm looking for Google Sheets to do something for me or perform a calculation or analysis. I'm going to type in equals and start typing quartile, and you'll see that it automatically, very quickly does that for me. But what I'm going to do is type in quartile, then type my range, exactly the same range that I use for minimum. It'll be the same through all of these. Importantly though, for quartiles, I need to identify which quartile I'm looking for. So I'm going to do the first quartile and hit enter. And we see that we get 24 as our first quartile. Just remind you of these two numbers. This is the minimum value. That should be obvious. The first quartile is that value for which 25% of the data is less than that. I'm going to cheat a little bit and skip over median, and I just want to find the third quartile. So actually in Google Sheets, I'm going to copy and paste that first quartile move, and all I need to do is change that number after the comma. I now want the third quartile, and I hit enter. And I get that the third quartile is 29. And again, that is the value for which is bigger or for which 75% of the data is less than. And we found how to find the median on Google Sheets already. Actually, if you remember from the conversation of median and the quartiles, I actually could have used that same quartile formula and just put a 2 for the second quartile. But let's just remind ourselves what we want to do is click under the median and type in equals median and simply just put this range in and hit enter. And I get that the median value, or the value for which 50% is less than and 50% is greater than, is 26. And finally, I want to find the maximum value. So what I need to do is simply under the maximum there, type in max, and then put parentheses around this region right here, or this range of data values, and I see that I get 35. So again, that's really most of the work in finding this 5-number summary. I'm now going to do the work by hand of showing you what the box plot will look like. What the box plot will be is a very simple but useful visualization of the spread of this data. As we talked before, we have these quartiles that give us an idea of these 25% chunks of where our data is located. We're soon going to talk about the idea of skew. And skew generally is this concept of where is our data? Is it mostly skewed towards the older ages or the younger ages? We might get an idea by this 5-number summary, but when you see the visualization, you'll see it's very easy to quickly see where does most of this data lie. And again, because we have these 25% chunks, we have this idea, this range between the first and third quartile, which gives us idea, by the way, between the first and third quartile, we know 50% of our data will lie. And so when you look at this box plot, it'll give you a beautiful visualization of how all of that data lies out and where it's concentrated. And there are a few different ways to represent a box and whisker plot or a box plot. We can do this horizontally or vertically. It won't matter. It's exactly the same. But what we do need in any case is some kind of axis to give us an idea of the range of values. So what I'm going to do right now is on this axis, I need to mark values between 19 and 35. In fact, to make it easy on me and to try to make this somewhat symmetrical or uniform, I'm just going to do little ticks by sets of 5. I'm going to start at 15. So I'll go 15 right here, and I'll choose a length that looks something like that and say that's 20. And about the same, I'm going to call this 25. And again, I'm just going to go up to 35. I could go past that to 40 and start at 10. It doesn't really matter. I just need to make it clear, hopefully to the reader of the box plot, of kind of this general spread. All right, so that's 5, another 5, 25. Let's say that's 30, right about there, and 35. And just because I got a little more room here, we can go all the way somewhere like this, and we'll say that's 40. All right, so all I need to do now is I'm going to mark each of these, not on this axis. Usually what we do, we'll represent this just above, just so it's clear and not too jumbled with all the information or the tick marks here of this axis I've created. So what I'm first going to do is mark 19. So 19 right here is the minimum value, so that's just here left of 20. Then I'm going to mark 24, that's just below 25. Then 26 is my median. I will mark that, so just after 25. I have Q3, third quartile, is 29. I'm going to mark that. And then 35 is my maximum value. All right, and so we call this a box plot, or more usually, I've heard box and whisker plot. So what we're going to do is create a box with this middle 50% of data between the first quartile and the third quartile. And how we do that is I'm just literally going to make a rectangle right here from those. Again, this value right here was the first quartile value. This was the third quartile value. This line right here represents the median value, that middle, very much middle of the set, where 50% of the data is before and 50% of the data is after. And then all I do, I create these whiskers where I'm just going to draw a line from this box to the minimum. And I draw a line from this box to the maximum. That's the beauty right there. This is our visual representation. Again, just to label all of these, we have our minimum value here. We have Q1 is represented by the start of the box. Q3 is represented by the end of the box. within the box, we can see our median value. And then finally, this last whisker at the very end right here, this is our maximum. Depending on the data and the analysis you're trying to make, this can be really useful given the information. In this case right here, here are some observations that I have. First of all, it doesn't seem too much that the max and the min are crazy outliers. I can do some analysis with that interquartile range and looking at my fences or the lower bound and upper bound of these possible outliers. But just visually, it doesn't seem too crazy. Again, the idea is this is 50% of the data, and then these represents the lower 25 and upper 25% of the data. It might seem a little bit, even as I say this, it's a little bit hard to see, but maybe this 35 is a bit of an outlier, but we're not going to get too worried about that. Interesting to me then is like, where does this box lie, that 50%? If it was skewed really young, it would seem that most of the data then is down here, or 75% of the data would be really low, and then maybe we'd have a lot of outliers or a few outliers. In the same way, the positioning of this box will give you an idea of that middle chunk of the data. But also, not just that, we see that our median here is actually pretty far left of this, on the left side of this box right here. Again, importantly, visually, what we're getting from this is this represents where 50% of our data will lie within that box. But this median is that 50% point, meaning, if you're following, in this pit right here and this bit right here is 25% of our data. It seems like there's a very strong concentration. 25% of our values for these ages are between this Q1 value of 24 and the median of 26. So 25% of our data lies within 24, 25, or 26-year-olds, which is very interesting. And that's really it. There's not much more. If you can find a 5-number summary by hand or with technology, Google Sheets, or your TI calculator can also do this very easily with 1var stats. You can find these 5-number summaries, mark on some kind of axes or some kind of number line these values. Again, don't do it right on the number line. Do it just above. This can all be done vertically with our scale going up and down. But this right here is called a box and whisker or a box plot.